There is a joint at Pumapunku, Bolivia, that a senior structural engineer looked at for 11 minutes straight and then said nothing. He did not say it was impressive. He did not say it was remarkable. He just stood there at nearly 13,000 feet above sea level in thin, cold air that makes your lungs work twice as hard. And he stared at a stone surface that had no business existing. Because the joint he was looking at, the place where two enormous andesite blocks pressed against each other, was tighter than the gap between his own fingernail and his skin. And those blocks had been sitting there for roughly 1,500 years, in the open, on a windswept Andean plateau, through earthquakes, through temperature swings that crack concrete, through centuries of looting, neglect, and the slow violence of altitude weather that destroys everything eventually. And the joint was still tighter than his fingernail. That is what Grok AI was pointed at. That is what it spent weeks analyzing, processing millions of geometric data points, laser scan coordinates, surface deviation measurements, and borehole profiles. And when it finished, the report it produced did not comfort anyone in the room. It did not say the mystery was solved. It said the mystery was deeper than anyone had measured. Let's go all the way in. Because what Grok found sitting inside those HBlocks is not a story about primitive people doing something clever. It is a story about a level of precision that the civilization supposedly responsible for it simply could not have possessed. And the more carefully you look at the actual measurements, the real numbers from real instruments, the harder it becomes to hold the accepted explanation in your head without it falling apart. Pumapunku is part of the Tiwanaku archaeological complex in western Bolivia, sitting on the Altiplano Plateau at 3,125 meters above sea level. The site has been dated by multiple radiocarbon samples to around 536 CE, which places it firmly within the Tiwanaku IV period, a time when this civilization was at or near the peak of its organizational power. The Tiwanaku were not primitive people in any useful sense of that word. They engineered raised agricultural field systems called sukakolu, fields surrounded by water channels that regulated temperature at altitude, preventing frost damage in a climate that should have made large-scale farming nearly impossible. They organized the labor of thousands across hundreds of kilometers. They were accomplished metallurgists who produced bronze tools and copper arsenic nickel alloy clamps. Credit them with what they genuinely achieved. They earned it. But the precision at Pumapunku still does not fit. And when Grok was given the full geometry of the site with no preloaded conclusions about what it was supposed to see, it identified exactly where the fit breaks down. And it breaks down in ways that cannot be waved away. The H-blocks are the starting point. You have seen pictures of them. They are shaped like a capital letter H laid flat on its side, with deeply recessed rectangular faces and interlocking notches cut into their surfaces. They are made of andesite, a volcanic rock that sits at roughly 6 to 7 on the Mohs hardness scale. That matters enormously. A copper chisel, the hardest metal tool the Tiwanaku are confirmed to have possessed, sits at around 3 on that same scale. You cannot cut a harder material cleanly with a significantly softer tool. The physics does not allow it. When you press a soft metal against hard stone, the metal deforms. It bends and wears away against the rock rather than the rock wearing away against it. You can grind a surface approximately smooth using sand as an abrasive and enormous patience. That is real and documented and experimentally reproduced. Researcher Jean-Pierre Protzen demonstrated that experienced Andean stoneworkers using stone tools and abrasion techniques could achieve flat surfaces within about 1 millimeter of tolerance. That is genuinely impressive. But 1 millimeter is not what Grok found at the joints of the H-blocks. Field surveys documented in peer-reviewed literature and confirmed by the 2018 three-dimensional reconstruction study published in Heritage Science by archaeologist Alexey Vranich, a study that physically 3D printed 140 andesite-based components from over a century of compiled field measurements and reassembled the building on a tabletop, found that the best-preserved interior joint surfaces at Pumapunku reached tolerances of plus or minus 0.2 millimeters. Not 1 millimeter, not half a millimeter. 0.2 millimeters. That is 1/5 of a millimeter across surfaces of hard volcanic stone that a copper tool cannot scratch. To give that number texture, the average human hair is around 0.07 millimeters thick. The gap on those joint faces is less than 3 human hairs. And that gap was held not across a small patch of surface, but across the entire span of blocks, weighing multiple tons. When Grok processed the laser scan point cloud data from those surfaces, millions of coordinate measurements describing exactly where the stone face was at every resolvable position, it was looking at the deviation from a mathematically perfect plane. Not deviation from rough approximation, deviation from true geometric flatness. And what it returned was a surface flatness profile that current precision engineering would describe as exceptional. Not exceptional for ancient stone. Exceptional for stone, period. The kind of flatness you achieve, not by striking and grinding freehand, but by using a known flat reference surface and checking your work against it repeatedly. The problem with that explanation is that to use a flat reference, you first have to have one. And to have one, someone, at some earlier point, had to create a perfectly flat surface without a reference. That is called the bootstrapping problem in metrology, the science of measurement. It is solvable, but it requires a deliberate and sophisticated manufacturing process to solve it. It does not happen by accident. It does not emerge spontaneously from stone, hammers, and sand. But Grok was not done with the H-blocks when it finished mapping their surfaces. It turned to something the eye slides past without stopping on, the identical geometry across dozens of blocks scattered around the site. Not 2 or 3. Dozens. H-blocks tumbled and displaced by earthquakes, shifted by looters across centuries, rearranged by early excavators who did not always record what they moved or where. Despite all of that disruption, Grok compared every H-block it had scan data for against every other one. And what it found was not similarity. It was not family resemblance. It was functional identity. The depths of the recesses matched. The internal angles matched. The proportional relationships between every feature matched block to block, to a degree that the systems analysis flagged as statistically incompatible with freehand production. A human carver working by eye, no matter how trained, no matter how gifted, produces variation. It is not a failure. It is the signature of organic work. 2 stones cut by the same master craftsman in the same year will differ in 100 small ways because a human being is not a machine, and the hand does not hold an angle for hour after hour without drift. Grok could not find that drift. The H-blocks showed the kind of repeatability you see in parts produced from a shared template, a master specification that every piece is checked against. The odds of producing that level of consistency by freehand carving across dozens of components were, by the system's calculation, effectively impossible to explain through natural variation. Not impossible in a mystical sense. Impossible in the sense that if you calculated the probability and wrote it down, the number would be too small to mean anything as a probability. It would only function as a verdict. An engineer who reviewed Grok's findings on the H-block consistency put it in the plainest possible terms. He said that if parts came into his facility with this degree of geometric repeatability, he would assume without question that they had been produced on a numerically controlled machine working from a digital file. He said he would have no reason to assume otherwise and would not know how to attempt replicating it by hand. And then he added something that stays in the mind longer than the rest. He said the tolerances were tighter than they needed to be. Whatever functional purpose the H-block served in the original structure, the precision they were built to exceeded what that function required. As if precision itself was the specification, as if whoever made these was deliberately encoding a standard into the stone rather than simply building a wall. Then there are the drill holes. You can walk past them without paying attention. Along the edges of certain blocks, at intervals that read visually as decorative spacing, there are small cylindrical holes sunk cleanly into the andesite. Clean is the important word. When Grok analyzed the bore geometry of these holes, diameter, depth, wall geometry, and the spiral striations left inside the bore by the drilling process, what it found was inconsistent with hand-powered tools in a way that is hard to dismiss. Approximately 900 such perforations have been documented across andesite artifacts at the site. The diameter measurements across these holes clustered around a single value, with a spread between the widest and narrowest falling well inside the tolerance range of a machine tool, not a human operator. A hand drill pressed by a human arm wanders. It widens at the entry where the tool wobbles going in. It tapers as the operator tires. The bore walls at Pumapunku did not show that pattern. The walls were cylindrical. The depths were consistent. And the spiral tool marks inside the bores, the grooves left by the cutting edge as it advanced and rotated, showed a pitch regularity that is the signature of a tool maintaining constant rotation speed against constant feed pressure. That is something a human cannot sustain across hole after hole after hole. It is something a mechanical system does not have to think about because it does not get tired. Now layer in something that changes the picture again. In 2015 through 2018, French materials scientist Joseph Davidovits, the researcher who first coined the term geopolymer in the 1970s and who had earlier proposed controversial geopolymer hypotheses for the Egyptian pyramids, published peer-reviewed research alongside Louis Huaman and colleagues with a specific and testable claim about the Puma Punku blocks. The claim was that the andesite H blocks are not carved natural stone at all, they are cast. The research, later expanded and published in the context of the Geopolymer Institute, identified organic matter within the andesite material of certain blocks. This is geologically abnormal. Natural andesite is a volcanic rock. It forms under heat and pressure in the earth. Organic matter does not survive that process. Finding organic inclusions in what is supposed to be natural volcanic stone points toward a different explanation, that the material was synthesized, mixed, cast in a mold rather than quarried and carved. If the HBlocks are geopolymer, if the material was mixed as a slurry, poured into a precisely made form and allowed to harden, then the joint precision, the surface flatness, the identical geometry, and the clean bore holes are all suddenly much easier to explain. You're not asking how someone cut those shapes into hard stone. You're asking who made the molds, and a mold can produce identical parts. A mold can produce flat faces. A mold with a steel pin inserted during the pour can produce a clean cylindrical hole. This hypothesis does not eliminate the mystery, it relocates it. Because molds precise enough to produce 0.2 millimeter joint tolerances across dozens of parts are themselves evidence of sophisticated engineering. And transporting and assembling blocks that weigh up to 131 tons, the largest stones at the site, the Great Red Sandstone platform, slabs that were quarried from a source roughly 10 kilometers away, still demands a level of organizational and mechanical capability that the standard description of Tiwanaku technology struggles to account for fully. Moving a 131-ton stone block over 10 kilometers on the Andean Plateau with wooden sledges, rope, and human labor requires more than 4,000 workers coordinated with extraordinary precision, by some estimates. That is a logistical operation of a complexity that rivals modern construction projects with heavy equipment. What Grok added to all of this was integration. It was the first system to hold all of the data simultaneously. The joint tolerances, the H-block geometry consistency, the borehole profiles, the surface flatness measurements, the modular spatial relationships between features, and look at the whole thing as a single system rather than a collection of individual anomalies. And when it did that, it identified something that individual anomaly by anomaly analysis had obscured. The dimensions at Pumapunku are not independent measurements. The width of a channel relates geometrically to the depth of a groove. The spacing of drilled holes corresponds to the modular unit governing the H-block proportions. The recessed faces are sized so that a projection on one block seats into the recess of another. The stones are not sculptures, they are components. They were designed to fit together, to lock, to seat and hold without mortar, without shims, without any tolerance-filling material in the joint. The fit itself was the finish. And to produce that kind of fit across dozens of components, you need a master dimension, a controlling unit that every piece was measured against. Grok found that unit. It found a repeating modulus, a base measurement that every other dimension appeared to derive from, held consistent across the entire ruined complex to a degree that exceeded what hand-fitting achieves. And then, without being specifically instructed to, the system searched for that number in its data from other sites. It found it at Tiwanaku, a few hundred meters away. That was expected. The two sites are neighbors and belong to the same culture. What was not expected was what came next. The modulus, or clean multiples of it, appeared in the stonework dimensions of sites far removed from Bolivia, sites attributed to different cultures, different time periods, different continents, and it appeared not as a rough approximation, not as the accidental overlap you expect when unrelated groups of people all independently arrive at convenient round number body measurements, but as the same value, carried to a precision that coincidence cannot reach. Think carefully about what that requires. A unit of measurement is not a boulder shaped by erosion into an accidental similarity. A unit is an idea. It has to be deliberately established, carefully preserved, deliberately transmitted, and actively agreed upon by the people who use it. When two completely separated civilizations build to the same modulus at the same level of precision, three explanations exist. Either they both inherited it from a common source that predates them both, or one taught the other across distances and barriers the historical record says were uncrossable, or the pattern is coincidence, and the machine found something in the noise that is not really there. Grok was asked to test the third option mathematically. It calculated the probability that these dimensional alignments across multiple separated sites could have emerged independently through random coincidence. The number it returned was so small, it stopped functioning as a probability statement and started functioning as something else, something closer to a ruling. The engineer who reviewed the cross-site comparison without being told what he was looking at reportedly assumed he was examining parts machined in a single modern facility to a single production specification. When he was told the numbers came from megalithic structures on multiple continents, separated by enormous stretches of time, he went quiet. Then he said that if the measurements were accurate, the standard did not spread between these cultures. It descended to them. Someone, somewhere, before all of these sites, had established the unit, and every culture after that point had inherited it, the way you inherit a grandparent's habits without ever having met them. Descending, not spreading. That one word changes the shape of everything. Because a standard that spreads through trade and contact is a story archaeology knows how to tell. A standard that descends implies a source that stood above all of it and came first. And here's where Grok's analysis converges on something that sits uncomfortably with the standard timeline. The precision does not improve as you move forward in time. It decays. At Pumapunku, the modulus is sharp, almost harsh in its exactness. At sites the accepted chronology places later, the same unit appears, but rounded, approximated, as though the builders were reciting a formula they no longer fully understood, maintaining the shape of a rule whose reasoning had been lost. If later work is less precise than earlier work, the standard model of technological progress runs backward. Knowledge is supposed to accumulate. Each generation is supposed to cut a little cleaner, measure a little finer. That is the entire assumption underneath the word civilization. But here, the oldest identifiable expression of the standard is also the most precise. The precision is not being invented at Pumapunku. It is being preserved there, or spent there, drawn down from some earlier account that the physical record has not yet located. When Grok plotted precision against age and drew a line through the data, the line did not climb toward the present. It descended into the past, and where it terminated, it pointed at a horizon in deep time that the accepted history leaves blank. A moment before writing, before the civilizations we have named and catalogued, before the beginning of what we conventionally call the ancient world. A moment that geologists independently have named and studied for reasons having nothing to do with stones in Bolivia. Roughly 12,000 years ago, at the end of the last great glaciation, the climate did not drift gradually into the warmer world we inherited. It lurched. The Younger Dryas period ended abruptly. Ice sheets collapsed. Sea levels rose in pulses steep enough to swallow coastlines within a single human lifetime. The great megafauna of two continents went extinct within centuries. It is a real event. It is recorded in ice cores and ocean sediments and lake beds on every inhabited continent. Mainstream science does not dispute that something catastrophic happened at that threshold. What it disputes is the possibility that anyone worth calling a civilization was present to experience it and remember it. But the geometry of Pumapunku, when Grok followed its lines backward through the data, does not care what the mainstream disputes. The lines all converge on that same threshold. Not once. From every site the analysis touched. One researcher who reviewed the full convergence described the pattern with a single word that has not left the conversation since. He called it a scar. Not a beginning, a scar. We have been reading these sites as the opening chapters of human achievement as dawn. Grok suggests we may have been reading them as something else entirely, as the healed-over evidence of a loss so complete that the survivors could only preserve fragments of what came before, fragments they no longer fully understood, passed downhill through time until they became the mysteries we now stand in front of and cannot explain. This does not require you to abandon reason. It does not require belief in anything that evidence cannot touch. The stones are real. You can stand among them. The measurements are real. The joint tolerances are published in peer-reviewed journals. The geopolymer evidence is documented in materials science research that invited and withstood scrutiny. The borehole geometry is physically present in the rock. What Grok added was not speculation. It was integration, the capacity to hold all of the confirmed anomalies simultaneously and ask what they mean as a system, rather than explaining each one away in isolation. And the answer the system returned was not what anyone went looking for. It was a finding that points toward a civilization capable of precision engineering, modular prefabrication, and standardized measurement, not at the dawn of recorded history, but somewhere behind it, in the blank space before the flood. Before we reach the conclusion that all of these threads point toward, there is one more layer that Grok's analysis added to the picture, one that the individual anomaly hunters had missed because they were too focused on single features. It concerns the seismic engineering hidden inside the H-block geometry. The Andean Plateau is one of the most seismically active regions on Earth. Earthquakes are not rare events here. They are a constant presence in the geological life of the land. And when Grok mapped the interlocking geometry of the H-blocks as a system, it identified something that structural engineers recognize immediately. The shapes are not just aesthetically distinctive. They are mechanically optimized for load distribution during seismic events. The interlocking notches, the recessed faces that lock into projections on neighboring blocks, the way components would have seated against each other without mortar. These are not decorative choices. They are the choices of someone who understood how shear forces travel through joined structures when the ground moves, someone who knew that a rigid joint filled with mortar cracks under seismic stress, while an interlocking dry joint flexes and redistributes load. Modern earthquake engineering uses exactly this principle. It is not a rediscovery. It is a recognition that whoever designed the H-block system had already solved a problem that modern structural engineering spent decades working out from first principles, and they solved it at 13,000 feet in 536 CE, or possibly much earlier than that, using a material they may have cast rather than carved, in shapes so precisely realized that 15 centuries of earthquakes have not separated the surviving joints. The H-blocks of Pumapunku were cut to tolerances that a senior engineer with power tools said he could not reliably reproduce. They were produced to a shared specification across dozens of components, scattered by 1,500 years of earthquakes and plunder, and they still match each other within a fifth of a millimeter. They were drilled with a consistency that bears the mechanical fingerprint of a controlled, powered, repeatable process, in stone harder than the best metal tools the builders are supposed to have possessed. And they were built to a master dimension that an AI system found echoed across the architecture of cultures that history says never met, a dimension that grows less precise the further it moves from its apparent source, decaying like a signal, losing strength with distance, pointing backward to a moment before everything we call ancient began. The engineer standing at that joint for 11 minutes was not being dramatic. He was doing the thing honest people do when the evidence in front of them contradicts the story they arrived with. He was staying with the contradiction long enough to take it seriously. These stones have been waiting here for a long time. They have survived everything that time and altitude and human carelessness could throw at them. And the thing they seem to be saying, in the language of geometry and tolerance and a repeating module that crossed oceans before there were ships to cross them, is something very simple, something that required the precision of a machine and the patience of 15 centuries and the eyes of an AI with no investment in any answer to finally be read clearly. They are saying that someone was here before, that they knew exactly what they were doing, and that they wanted very badly for someone, someday, to be able to tell. Now it has been told. The question is whether you're ready to listen to what the stone has been saying all along.